Hello, welcome back to the Looc. In this segment we are going to look at the concept and the uses of inheritance in object-oriented programming. In particular, we'll look at how inheritance promotes software reusability, how to create a derived class that inherits attributes and behaviors from a base class, how to use the access modifier protected to give access to a base class member, how to access base class members with base, the keyword base, how constructors are used in inheritance hierarchies, and the methods of class object, the direct or indirect base class of all classes. So that's our plan, and we are going to look at it using an example called commission employee and its derived class commission employee base plus commission employee inheritance class structures. So inheritance allows programmers to create a new class that can absorb an existing class's members, such as a derived class. A derived class normally adds to its own fields and methods to represent a more specialized group of objects. And inheritance is done by reusing proven and debugged high-quality classes created before. So a derived class really absorbs the members, both attributes and methods of a base class or a parent class, and thereby reuses them so that we can avoid recoding the same functionality. In particular, we call a direct base class is the base class from which the derived class explicitly inherits members. We can also call it a parent class. An indirect class is any class above the direct base class in the class hierarchy. So this would be like grandparent and great-grandparent and so on classes. And in C#, all class hierarchies begin with a class object, so there's the highest level class of all classes. Generally, inheritance represents an is-a relationship between classes. For example, if we have classes car, truck, and vehicle, then we can say the car is a vehicle and the truck is a vehicle. In this case, vehicle would be the base class and car and truck would be two derived classes. And new classes, therefore, can inherit from thousands of pre-built classes and class libraries. So we can even use a huge class library that is already created and written by someone else and add new classes by inheriting. So there are some examples coming up, and base classes are generally more general and derived classes are more specific, just like in the car and vehicle example. The car is a more specialized case of vehicle, and so is truck, and vehicle is a more general concept that can include other vehicles such as airplanes or trains. So some examples here are base class student and derived classes graduate student or undergraduate student. Student is the more general, graduate student and undergraduate student are more specialized cases of student. Or base class could be a shape class, and of its derived classes could include circle, triangle, and rectangle classes. In Java, another programming language similar to C#, base classes are often also called superclasses, and derived classes are often called subclasses, and inheritance is often called subclassing. So, for example, shape would be called a superclass, and circle, triangle, and rectangles would be three of its subclasses. Another example is the loan class, and various derived classes from it could inherit methods and properties such as car loan as a class, home improvement loan as a class, and mortgage loan as a class. Another example, employee could be a base class, and faculty class, staff class, hourly worker class, and commission worker class could be subclasses or derived classes of the base class or superclass employee. Bank account could be another example of a base class, and derived classes can be created inheriting from bank account, such as checking account or savings account. URL is capable of describing class hierarchies, inheritance hierarchies, and arrows point from the derived class to the base class and represent is-a relationships. So here is a class hierarchy example in which administrator and teachers are subclasses or derived classes of faculty. Faculty and staff are derived classes of employee, and employee, student, and alumnus are all derived classes from the highest level base class community member. We can look at another example of this. For example, circle, square, and triangle are derived classes from two-dimensional shape. Note the arrows pointing upwards from the derived to the base class, or sphere, cube, and tetrahedron could be derived classes of the base class three-dimensional shape. Arrows pointing up again, and each arrow represents an is-a relationship. One level up, two-dimensional shape and three-dimensional shape could be subclasses of an even more general shape class, and arrows pointing out indicate inheritance pointing towards the base class and therefore represent is-a relationship. So two-dimensional shape is a shape and three-dimensional shape is a shape. Objects that are created out of classes that extend or inherit from a base class can be treated as object of the base class as well. So a circle object is also a two-dimensional shape object at the same time, simultaneously. However, base class object cannot be treated as object of the derived classes, so two-dimensional object cannot be treated as a circle object. It's not guaranteed to be a two-dimensional object, can be a triangle object or a rectangle object. So it doesn't make sense to say that a two-dimensional object is necessarily a circle object. So it cannot be reversed that way. A derived class can further customize methods it inherits from its base class. So it can inherit them without changing them and using the same way as the base class uses those methods, or it can modify them, and in that case we say that the derived class overrides or redefines the base class method with an appropriate implementation. In addition to private and public access identifiers, we also have a third access level called protected. So a base class's private members are inherited by derived classes but are not directly accessible by derived class methods and properties. So code in derived classes does not give access to private members of a base class because they are private, so they can be only accessed by code belonging to the same class. However, if we change the access specifier to protected, then a base class's protected members can be accessed by members of that base class, of course, like private, and by members of its derived classes. However, no one else. So classes that are not related to the base class by a class hierarchy cannot have access to protected members. Only derived classes can. So it's important to remember that private members cannot be directly accessed. That's why there's the protected keyword, and therefore derived classes have to use non-private methods and properties such as public or protected to access members of a derived class that are private. And there are reasons for this, such as maintaining the integrity of the code. So if there's a base class that is well tested and it correctly handles its properties and correctly calls its methods, that would be lost if derived classes can change that. For example, a base class might have proper checking, proper input checking, so that only valid data is written into properties. But if we allow derived classes to change that, then the well-tested nature of the base class would be lost. So here is an example. A class called commission employee. An employee is paid a percentage of their sales. Note that commission employee, note that inheritance in C#, similar to C++, is indicated by a colon. So public class commission employee colon object indicates an inheritance, so that commission employee inherits from the class. The class commission employee inherits from the class object. This is always the case, so even when colon object is not added, every class in C# automatically inherits from the class object. But in this case we make it explicit. When a class inherits from a base class, we also call it extending, so a class extends a base class. In this case, look at the commission employee class. It has a number of private attributes. First name, last name, social security number are strings. Gross salary, weekly sales, and the commission rate, the rate of commission, are two private decimal number type attributes. Then there is a constructor, public. Like all constructors, commission employee, no return value, same name as the class, and has 5 parameters. We pass in 3 strings, first name, last name, and social security number, and 2 decimal numbers, sales and rate. And when this constructor is called to create a commission employee object, then, as the comment indicates, there's an implicit call for the class object constructor. It is a constructor that has an empty body and doesn't take any parameters. We don't have to specifically put it in there, but technically the constructor of the base class object is called. It doesn't do anything, returns control right away to the constructor of our class, which is commission employee, and then we set the first name to the first parameter, first last name to the second, social security number to the third parameter, and gross sales and commission rate are also set from the 5 parameters that are passed into the constructor. Then we create properties to make these private attributes accessible. First name is the first property. It's a read-only property, so only the get accessor is implemented. Meanwhile, by returning the private attributes, first name, same goes for last name. Only the get accessor is implemented as a public property, and as a public accessor, the set is not making them read-only. Social security numbers handled similarly. And then we get to the numerical properties. One of them, gross sales, which have both get and set, accessor and mutator implementation. So the get method just returns the value of the gross sales, the decimal. Meanwhile, the set sets the gross sales to the value passed into set. However, it also has some input checking, some validity checking, so value has to be a non-negative number. Otherwise, we throw an exception, an argument out of range exception, with a message that gross sales with a certain value that is, say, negative must be greater than or equal than 0. And the same goes for commission rate as a get and set method, and again the set mutator does validity checking, so a commission rate has to be between 0 and 1, has to be positive, and has to be less than 1 because it's a fraction that the employee earns of the sales, and we throw an exception if that's not the case. Then a public method called earnings is defined, which returns the commission rate times gross sales. So the gross sales are the total sales of the employee are multiplied by the commission rates. A fraction of it is the employee's earnings. And that is an interesting method, the toString, which as a representation of the commission employee object. Public override string toString. The reason we have a new keyword override in there, because that's a keyword that indicates that the method we are writing here is actually overriding or redefining a method of the base class. So it's important to know that object, as the root base class of all classes in C# has a toString method declared in it, and we have to override that. And when we do that, the keyword override indicates the situation. So toString is overriding the object toString method and replaces with what the code here says. So return string.format, a formatted string with formatting parameters, 8 of them, 0, 1, 2, 3, 4, 5, 6, 7, 6, I think it's a little bit misnumbered, so the 8 should really say 7, and we return the first name, last name, and security number after appropriate labels, and the gross sales and the commission rates as well, as appropriately formatted and in a new line placed after the first name and last name, and also after the social security number, and the last three the numbers, the last two the numbers are returned formatted as currency for gross sales, and a 2-digit floating point number for commission rate. So again, the colon indicates that a class extends a class to the right of the colon. In other words, the class is a derived class of the base class, which is on the right of the colon. Object is a base class, a root base class of which every other class directly or indirectly inherits from or extends. And if a class does not specify that it inherits from another class, it implicitly inherits from object. We explicitly put in our code, but that's implicitly is always the case. And the compiler will set that as a base class if we don't explicitly put it in our code. So a few more comments about the commission employee class, that having private instance variables is good software engineering practice. We don't want to have access to private implementation details of a class. Constructors are not inherited, so derived classes have to have their own constructors. They have a different name than their base class, so their constructors accordingly have to have a different name as well. And the default empty constructor of the object class doesn't do anything, so it is called, but it's only for a compiler to use. In code, we don't do anything with it because its body is empty. and a class constructor we always call the base class if there's no other than the object class is parameterless or default constructor. So here is some details of the toString method. It overrides the object class's original toString methods. It always returns a string object that represents the actual object, and this toString method in object is a placeholder, and it expected that it will be overridden by a derived class. And to override a base class method, in a derived class we must declare the method with the keyword override. So we are indicating that this is overriding a base class method. And for overriding, the method has to have the same signature, so-called signature, as the base class method, and the signature made up of the name and number of parameters and their types, as well as the return type. So we cannot change the signature during overriding. In particular, it cannot have a different access modifier either. So if the base class was public, private, or protected, then the overriding method has to be the same. So public cannot be changed to protected or private, and so on, and vice versa. And we have a test class that tests the commission employee class by creating an employee object with the parameters indicated, and then we display its various properties: first name, last name, social security number, the gross sales, and the earnings. Then we change the gross sales and the commission rate, and this time we display the employee in a different way. Namely, we are displaying a header updated employee information obtained by toString, and we then use the earnings method to display the revised earnings, and the employee object is directly will be placed the write line, which automatically invokes its toString method, because write line works with strings only. So without having to indicate it, toString will be called, and then we add the earnings of the employee. So let's look at this program first. I'm not going to type it because it's quite long and it's already done. So here is our commission employee object, a commission employee class that is derived from object or extends object. There are the private properties there, first name, last name, social security number, and gross sales and commission rate. Then comes the constructor, commission employee constructor, has 5 parameters: first, last, social security number, decimal sales, and decimal rate, which are all set within the constructor. And then, as we discussed, there are properties implemented for public properties for these private attributes. First name read-only, so only its get method is implemented. Likewise last name, and likewise social security number. And then for gross sales and commission rate, we implement properties with both set and both get and set defined, so both accessor and mutator public methods are provided, and the public set methods perform validity checking. So the value has to be greater than or equal to 0 to be accepted and set as the value that gross sales will have, otherwise we throw an exception, and the same for commission rate. So this will be public properties. And then we implement the earnings method, which returns the commission rate times gross sales product. So the sales are multiplied by the commission rate, and the toString method that has the override keyword in its definition to indicate that it redefines a method of the base class, in which case it is the class object. So we display actually 9 different pieces of data about the employee. First name, last name, social security number, and so on. And the last two are numbers, so one of them is displayed as currency there, and that's gross sales, and commission will be displayed as a 2-digit floating point number. So that's our toString method, and in between we display various strings, and that's why there are so many 9 different pieces of this output, because it includes not only data from the employee object, but also kind of label strings like commission, employee, social security number, and so on. So that's our commission employee class, and to test it, we are going to use the commission employee test class that contains the main method, and then we create an employee object calling the constructor, and we pass in first name, last name, Sue Jones, the social security number, and 10,000 as a monetary data is the sales, and 6% is this employee's commission rate. And then we display them these properties piece by piece all the way to the earnings, and then we change the gross sales and the commission rate to different values. Then we set it in the constructor, and then we redisplay the employee as a string. So toString will be automatically called when we display an employee in a method like WriteLine, and then we add the earnings as well. So if we clean and then rebuild the solution, so it's taking a little time to clean, and then it's still cleaning. It takes a little time, unfortunately. Okay, so it's completed, and then we rebuild it. Recommend rebuild instead of build, so that everything is guaranteed to be actually rebuilt. If it's successful, we can test the code, Control F5 to run it without debugging, and here comes the output. So employee information obtained by properties and methods, and there are all the data from first name all the way to earnings, and then updated information obtained by toString, and only the earnings are a data item that we use the separate method. All the rest of them are simply part of the toString method. So other than the earnings, the rest of them are toString outputs. So that's our original commissioned employee class. At the next segment, we'll look at how to refine this class using first a separate class and then using a derived class to inherit from this class.